Alrighty, section 7.3, rational exponents. So before you used the laws of exponents to find products and quotients, and now we're going to evaluate and rewrite expressions involving rational exponents. Remember, rational has the word ratio in it, so it's like fractional exponents. And then we're going to solve equations involving expressions with rational exponents. So some new vocabulary we're going to encounter, of course, rational exponent, but also cube root, something called the nth root, and an exponential equation. So it's important to protect your skin with sunscreen to prevent damage. The sun protector factor, SPF, sun protection factor rather, SPF of a sunscreen indicates how well it protects you. Sunscreen with an SPF of F absorbs about P% of the UVB rays, where P, the percent, is equal to 50 times the SPF, whatever it is, to the 0.2 power. What does that mean? Well, you know that an exponent represents the number of times the base is used as a factor, but how do you evaluate an expression with an exponent that is not an integer like this one right here? Well, let's investigate rational exponents by assuming that they behave like integer exponents. So for example, if you have b to the 1/2 squared, well, the power property says that if you have an exponent, a power raised to a power, you multiply, or you have sorry, I messed that up. If you have b to the 1/2 squared, that means you multiply b to the 1/2 2 times. Well, the product of powers says if you multiply like bases, you add the exponents. So 1/2 plus 1/2 is 1. So b to the 1/2 squared is the same as b to the first, or just b. Well, what's that mean? It means that b to the 1/2 is a number with a square equal to b. So b to the 1/2 equals the square root of b. All right, so the rational exponent of 1/2 for any non-negative real number b, in other words, it can be 0 or a positive, b to the 1/2 is the same as the square root of b. So 16 to the 1/2 power is equal to the square root of 16, which is 4. 38 to the 1/2 power is equal to the square root of 38, which you could do square root of 38 on your calculator, but without a calculator, you just leave it as square root 38. All right, so let's try a couple. Write each expression in radical form, or write each radical in exponential form. So what would 25 to the 1/2 power mean? Well, 25 to the 1/2 power, the half power is the same as the square root, and the square root of 25 is, you got it, 5. How about square root of 18? Square root of 18, well, it's already in radical form, so we can rewrite it as in exponential form as 18 to the 1/2 power. How about 5x to the 1/2? Be careful with this one, because a lot of people would mistakenly write the answer as square root of 5x. But be careful. The 1/2 power is just on the x. Okay, if it was on the 5 and the x, it would be written like this. And that would be equal to the square root of 5x. But it's not written like this. It's written with that 1/2 just on the x, so that you can convert that to the square root on just the x. Okay? Here, the reverse type of thing is happening. You have a square root of 8p. A lot of people would mistakenly write that as 8p to the 1/2 like this. But that means 8 square root p. That's what that means. This one, you'd have to use the parentheses and write it as the quantity 8p to the 1/2. Okay, just be careful there. Whatever the exponent is on, or the 1/2 exponent is on, that's what gets the square root around it. Whatever the square root is around, that's what gets the 1/2 exponent when you're rewriting it. All right, so here's a couple for you to try. Go ahead and pause the video. All right, we're back. What you get? So for 1a, a to the 1/2, pretty straightforward, is square root a. Square root 22 would just be 22 to the 1/2. 7w quantity to the 1/2. This is the case where the 7 and the w are grouped together with the 1/2 exponent. So the 7 and the w are grouped together under the square root. Here, 2 square root x, only the x is in the square root, and you would put the 1/2 exponent just on the x, not the 2. Okay? All right. Well, you know that to find the square root of a number a, you find a number with a square of a. In the same way, you can find other roots of numbers. If a cubed equals b, then a is the cube root of b. If a to the n equals b for a positive integer n, then a is the nth root of b. So for any real numbers a and b and any positive integer n, if a to the n equals b, then a is an nth root of b. In symbols, if a to the n equals b, then you have the nth root. It's the same thing as the square root, but you have the little number right here that indicates the root. Okay, so because 2 to the 4th equals 16, 2 is a 4th root of 16, and you can write the 4th root of 16 equals 2. Because 2 is the 4th root, you have a little 2. It's called the index, which indicates the root that you're taking. If you just write it like this, no little number here indicates square root, like there's a 2, like it's understood that there's a 2 there, kind of. And that would mean square root of 16 is 4. But if you have a 4th root of 16, that's going to be 2. All right. Since 3 squared equals 9 and negative 3 squared equals 9, both 3 and negative 3 are square roots of 9. Similarly, since 2 to the 4th equals 16 and negative 2 to the 4th equals 16, both 2 and negative 2 are 4th roots of 16. The positive roots are called principal roots. Radical symbols indicate principal roots, so the 4th root of 16 equals 2. In other words, if you just have a regular old radical, you automatically take the principal root, the positive root. Okay, but if it said like negative 4th root of 16, your answer would be negative 2, because that indicates the negative root. Okay? Alrighty. So let's try a couple. Let's simplify the cube root of 27. Well, you can think of 27 as 3 times 3 times 3, so the cube root of 27 would be 3. Just like square roots, you need to find a number that multiplies by itself to get the square root. Cube roots, you need to find numbers that you can multiply 3 factors of it. Fifth roots, you'd need numbers you multiply 5 factors of them to get 32. Well, the 5th root of 32 is 2 times 2 times 2 times 2, which is 2. All right, so the 5th root of 32 is 2. Let's try a couple. Go ahead and pause the video. All right, we're back. So the cube root of 64 is the cube root of 4 times 4 times 4. And since 4 times 4 times 4 is 64, the answer is just 4. Okay. When you take the cube root, you get rid of the symbol. Okay, I wouldn't write the cube root of 4 as my answer, because the cube root of 4 is a whole nother problem. Okay, it's kind of like when you do 3 times 6 and you get 18. You performed the multiplication operation, so you don't write the multiplication symbol again. Okay, cube root or nth root or square root or 5th root, whatever the root is a symbol that means to take the root of it. It's an operation symbol. So once you perform that operation, you don't write the symbol again. Okay, so the 4th root of 10,000. Well, 10,000, I need 4 numbers that multiply together that give me 10,000. And it's actually 10 times 10 times 10 times 10. So the 4th root of 10,000 is just 10. Pretty cool. All right, like square roots, nth roots can be represented by rational exponents. So b to the 1 over nth power to the nth power is equal to b to the 1 over n times b to the 1 over n times that many factors of it. Well, you would just, if you multiply that many like bases, you just keep adding all the powers together, and you would get b to the n over n, or just b. So b to the 1/nth power is a number with an nth power equal to b. So b to the 1 over n is equal to the nth root of b. So for any positive real number b, any integer greater than 1, b to the 1 over n is the nth root of b. So 8 to the 1/3 is equal to the cube root of 8, or cube root of 8 is 2. Okay, let's try a couple. 125 to the 1/3 power means the cube root of 125. Well, that means I need to find 3 factors that are the same that multiply to 125. If I can do it, then I can take the cube root. Well, that's 5 times 5 times 5, so the cube root is just 5. 1,296 to the 1/4 power, I can write as the 4th root of 1296. And that means I need to find 4 numbers that multiply together to give me 1296. Well, turns out it's 6 times 6 times 6 times 6. So the 4th root of 1296 simplifies to just 6. Alrighty, so let's do 27 to the 1/3 power. 1/3 power is the same as the cube root, so that means the cube root of 27, which is 3 times 3 times 3. So the cube root of 27 is just 3. 256 to the 1/4 power is the 4th root of 256. And 256 is the same as 4 factors of 4 multiplied together. So the 4th root of 256 is just 4. All right. Now, the power of a power property allows us to extend the definition of b to the 1 over n to b to the m over n. What does that mean? Well, b to the m over n can be thought of as b to the 1 over n power to the mth power. Because remember, when you have a power to a power, you multiply the exponent. So 1 over m times m, 1 over n times m would be m over n. Okay? So you could rewrite that in one of 2 ways. You could write it as the nth root of b, all of that raised to the mth power, or the nth root of b to the m. Okay, whatever it is, the numerator number becomes the exponent, and the denominator number becomes the root. You see that? Okay, so if I have 8 to the 2/3 power, I can write it as the denominator is 3, the numerator is 2 in the exponent, so the 3 becomes the root and the 2 becomes the exponent. I could write it as the cube root of 8 squared, or you could write it as the cube root of 8 squared. Either way, okay? If you did cube root of 8 squared, you take the cube root of 8, which is 2. 2 squared is 4. If I did the cube root of 8 squared, I would have to do the 8 squared first, which is 64. And then 64 can be thought of as 4 times 4 times 4. And the cube root of 64 is 4. Same thing. You should get the same answer because it's the same problem, just written in 2 different forms. Okay? So let's try a couple. The 64 to the 2/3 power. I can write that as the cube root of 64 quantity squared. The reason I did that instead of the cube root of 64 with the 64 squared is because it's easier kind of to take the cube root of 64 first, because that makes the number smaller, and then square that. Okay, so the cube root of 64, we just did it a minute ago, is 4, and then 4 squared is 16. This one, I'm going to write it as the square root of 36 quantity cubed. Again, because it's easier to take the square root of 36 and then cube that answer than it is to cube 36 first and then take the square root. You would get the same number. You would get the same answer. Okay? It's just easier to do it for mental math purposes this way. So the square root of 36 is 6. 6 cubed is 216. And that's our answer. All right, here's a couple for you to try. Go ahead and pause the video. All right, we're back. What you get? So 27 to the 2/3 power is the same as the cube root of 27 squared. The cube root of 27 is 3 times 3 times 3 squared. So the cube root of 27 is 3, and 3 squared is 9. Okay. This one is the 4th root of 256 to the 5th power. Now 256 can be thought of as 4 times 4 times 4 times 4. So the fourth root of 256 is just 4 to the fifth power, and 4 to the fifth power is 1024. Okie dokie? All right. Well, that's it for this first video of this section. Stay tuned for the next one.